Hello friends, so here we are with another question on electric charge and Coulomb's law. So here we have been given that we have two small spheres, each of mass m and charge q, which are suspended with insulating threads of length l of negligible mass from a rigid support. In equilibrium, each thread makes an angle theta with the vertical. We have to show that q square is equal to 4mg L square sine square theta tan theta 4 pi epsilon 0. Okay, so first we have to draw a diagram converting the information which have been given so that we can understand this question in a better way. So here let's say we have a point from where we have two spheres, okay, two spheres which are suspended from this point. Okay, and let's say the gap between them is this. Okay, this. Now here the mass of each sphere is m and it has a charge q. The length of the string is L. Okay, this length. And another important thing is that each sphere, it makes an angle theta with the vertical. This angle is theta. This is 90 degree. So obviously this will be 90 degree minus theta. Okay, so let us denote them names. Okay, let's say this is O, this is A, this is B, and let's say this is C. Okay, so let us consider each sphere. Let us consider the sphere at point A, okay, separately. So we have considered this sphere here, okay. So here on this sphere there are different forces acting. Okay, first is the electric force of repulsion. Okay, this will be acting in this direction because the two spheres are identical, similar. So the electric force of repulsion will be acting away, pushing it away because of this charge here. Okay, this q charge here. Now another thing, the force acting will be the gravity force, mg, mass multiplied with acceleration due to gravity. And another force is the tension force acting along the length of the string, which is T. This angle here is 90 degree minus theta. So if we resolve the tension force into two components, it will be first along the horizontal, it is T cos 90 degree minus theta, which is equal to T sin theta, and another one is along the vertical, which is T sin 90 degree minus theta, which is equal to T cos theta. Don't get confused. Here it has been given that this angle with the vertical is theta, so obviously this will be 90 degree minus theta. Along the horizontal it is cos, T cos 90 degree minus theta. We know cos 90 minus theta is sin theta, so that's why it is T sin theta along the horizontal. This one is T sin 90 degree minus theta. Sin 90 degree minus theta is cos theta, so that's why it is T cos theta. So now all we have to do is resolve we have resolved the forces along different directions. Now we have to equate them. So here Fe is equal to T sine theta and Mg is equal to T cos theta. Okay, now Fe by Mg T sine theta by T cos theta, T gets cancelled, this is equal to tan theta. Now here from this diagram, tan theta here is equal to perpendicular by base tan theta, which is equal to how much? AB by OB, isn't it? AB by OB. So that will be, so here it will be, so here we have got this expression. Okay, so here we don't need to find out anything about tan theta because in the proof we have, there is tan theta expression, we don't have to do anything with it. So now here Fe is equal to mg tan theta, Fe is equal to mg tan theta. We have got up to this point. Okay, so now we know that the electric force between two charges is given by 1 by 4 pi epsilon 0 q1 q2 by r square, where r is the distance of separation. Here the distance of separation is equal to AC between two charges placed at A and C. Two charges that are placed, okay, at A and C. AC is equal to, if you see, it is twice of AB. AB is nothing but L cos 90 degree minus theta. Okay, this much, which is equal to L sine theta. So AC is equal to 2L sine theta, this one. So if we substitute here, it will become 1 by 4 pi epsilon 0, two identical charges small q, q square by 2L sine theta whole square. So this is equal to Fe. That implies q square by 4 pi epsilon 0 2L sine theta whole square is equal to mg tan theta. We have to find out, show that q square is equal to this much. So that implies q square is equal to 4 pi epsilon 0 2L sine theta whole square mg tan theta. See if it is coming true or not. Okay, if we open this 2L sine theta whole square, it will become 4L square sine square theta mg tan theta 4 pi epsilon 0. See, yes, it is coming true. 4 mgl square. Okay, let us put it in proper order. 4 mgl square sine square theta tan theta 4 pi epsilon 0, that is equal to q square. So we have proved it. We have shown that q square is equal to this much, 4 mgl square sine square theta tan theta 4 pi epsilon 0. So this question was again about Coulomb's law, yes, but it involves some concepts of mechanics also, because the force of gravity, the force of tension on the string, that also came into play. So again, it's a very good question, combining a lot of other concepts from other, branch of physics also. Okay, so Here we have proved it. Hello friends, so here is another question on electric charge and Coulomb's law, and the question is that a free pith ball of mass 6 grams, it carries a positive charge of 1 by 3 into 10 to the power minus 7 Coulomb. What is the nature and magnitude of charge given to a second pith ball fixed 0.05 meter vertically below the first pith ball so that the upper pith ball is stationary? Okay, so this is the question. Now let us try to convert it into the form of a figure, a diagram. So it has been given that we have a pith ball, a free pith ball, okay, this is the pith ball. It has a mass of 6 grams and it has a charge of let's call it Q1 of plus 1 by 3 into 10 to the power minus 7 Coulomb. This is the upper pith ball. Now we have below it another pith ball, okay, which is exactly 0.05 meter below it. Now the charge on it is unknown, we don't know, we have to calculate it, the lower pith ball. Now it has been asked what should be the value of this charge such that this upper pith ball, it does not fall down under the influence of gravity, because gravity force, it will act on this downwards, which is equal to mg because of its mass. Okay, so now here, in order to stop it from falling down, and we don't want it to move upwards also, we want it to remain stationary. So if we take this upper pith ball, okay, this upper pith ball, two forces are acting on it. First is the downward force because of its weight, gravity, under the influence of gravity. And if we want it to remain stationary, we have to supply an equal and opposite force in the opposite direction, and that will be because of the force of the electric force or the electrostatic force of repulsion. Okay, and only when this repulsion force will be equal to the gravity force, then this upper pith ball will remain stationary. If the repulsion force will be more than the gravity force, it will move upwards. If it will be less than the gravity force, it will keep on moving downwards. We want it exactly equal. Now the electrostatic force of repulsion between these two charges is determined by Coulomb's law, which is 1 by 4 pi epsilon 0 q1 q2 by r square. R is this much, 0.05 meter. So that is equal to 9 into 10 to the power 9 into 1 by 3 into 10 to the power minus 7 Coulomb, 1 by 3 into 10 to the power minus 7 Coulomb into q2 by 0.05 whole square, 0.05 whole square. This is the force of repulsion. It should be equal to the gravity, the weight of the electron, the weight of the pith ball. Now the mass of the pith ball is given, it is 6 gram. If we convert it into kilos, it is 6 into 10 to the power minus 3 kgs multiplied with the acceleration due to gravity. Okay, that is the gravity force mg. Mass is given 6 grams, 6 into 10 to the power minus 3 kilos, we convert it into kilos, multiplied it with acceleration due to gravity 9.8. So here Q2 will be equal to 6 into 10 to the power minus 3 into 9.8 into 0.05 whole square by 9 into 10 to the power 9 multiplied with 1 by 3 into 10 to the power minus 7. So if we calculate this, then the value of Q2, it will come around, Q2 will be equal to, so it is coming around 4.9 into 10 to the power minus 7 Coulomb. Okay, so it is coming around 4.9 into 10 to the power minus 7 Coulomb. Okay, so this is the value of this lower pith ball, the charge on the lower pith ball, so that the force of repulsion, which is opposite to the gravity force, and that will exactly counterbalance the downward acting gravity force in the opposite direction, the upward direction, and it will keep this upper pith ball stationary. Okay.